The process of recovering and recharging hundreds or even thousands of pounds of refrigerant in and out of a chiller is quite a bit different than the process of recovering and recharging a small AC unit. At some point in your career you will likely need to recover refrigerant, make repairs, and recharge large chillers with hundreds or even thousands of pounds of refrigerant. If done properly, you can move thousands of pounds of liquid refrigerant in and out of a machine in a day. In this video we're going to be walking you guys through what that process looks like on a large Daikin chiller. We will be using a visual representation of a Daikin centrifugal chiller for educational purposes only. The way you recover refrigerant on every machine is slightly different depending on many factors, and should only be performed by properly trained professionals. This video is not a step-by-step guide. It is meant for educational purposes to give you guys insight into how service is performed on large chillers, and should not be attempted unless you are a properly trained professional. If you make a mistake, you will freeze up your machine and flood the system with water, resulting in a substantial amount of downtime and possibly ending your career early because you got injured. In order to set this up, you will connect the discharge of the recovery machine to the top of the evaporator. Then you will connect the suction of the recovery machine to the vapor port on the top of the refrigerant cylinder. After that, you will connect a hose from the bottom of the condenser to the liquid port on the refrigerant cylinder with a liquid sight glass in between. A quick tip: if you are switching between many tanks, the use of refrigerant ball valves will make it easy to swap your hoses around and switch between tanks without losing any refrigerant. You should also use a minimum of 3 1/8-inch hoses when recovering large amounts of refrigerant. 1/2-inch and 3/4-inch hoses are ideal if you are doing this regularly. Alright, before you start the recovery machine, make sure that expansion valve is wide open and your pumps are off. This lets all the liquid refrigerant drain down to the condenser and allows the pressure to build in the chiller during this first part of recovery. This will help ensure all of the liquid gets out of the machine, and will make the entire recovery process more efficient. This configuration is commonly referred to as the push-pull method. At this point you can start your recovery machine. A quick note on how the push-pull method works. This process is so efficient because it uses physics to move the refrigerant, rather than just pumping power from your recovery machine. The recovery machine lowers the pressure in the tank, and increases the pressure in the chiller at the same time. This pressure differential between the chiller and the recovery cylinder is what starts the process of liquid refrigerant flow. Think of this like you are tipping a bottle full of water upside down and trying to drain all of the water out of it. The water will gurgle and slowly drain as the pressure on the top side of the water and the outlet of the bottle try to equalize. Now poke a hole in the bottom of the water bottle and all of the water rushes out of the bottle rapidly because the pressure is equalizing at the same rate that the water is leaving the bottle. This is the same physics behind using the push-pull method of refrigerant recovery. Okay, back to it. You can check your progress with the use of the sight glass on the hose from the condenser to the liquid port on your tank. Once all of the liquid is out of the sight glass for 10 minutes, and only vapor is left, reconfigure your hoses, and switch over to vapor recovery like you would on any other AC unit. Be sure that all of your pumps are running during this step, and keep going until the whole machine hits 40 degrees saturated on your PT chart. If you're working with 134A, that's around 35 psi. After that, you will look for cold spots on the machine, and use your pressure gauge on various ports to make sure that there is no liquid refrigerant trapped in the machine. Then either take a break or continue to run the evaporator pumps, and maybe even warm the bottom of the condenser and other cool points with a heat gun. You'll do this until you are 100% certain that you have all of the liquid refrigerant out of the machine. All of this will be done with the recovery machine off. After you warm the machine and let it sit for a minimum of 1 to 2 hours with all of the pumps running, then restart the recovery machine. If you have to do all of this multiple times to be 100% certain, then do it. This step is extremely important. After you're done recovering the vapor, make the repairs you need, pressure test the machine, then evacuate the machine, and perform a decay test. I'm usually a little paranoid, so I'll start up the vacuum pump for a little bit longer after I'm done with that to be 100% certain no air was let into the system when I removed my micron gauge. Recharging the machine the exact opposite of the way you pulled the refrigerant, except for the last step. When you're recharging the machine, you will add vapor to the system first, until you get the saturated refrigerant pressure above 40 degrees. If your hose starts to frost up, or the vessel starts to get cold, stop. Take a break and let everything warm up. It is extremely important that you keep the entire vessel above freezing to prevent your tubes bursting. Beginners and seasoned technicians alike have done this. I've been lucky enough to hear the horror stories from other technicians before I made the mistake myself. After you have verified that you have achieved 40 degrees saturated on your entire machine, you'll push-pull the liquid refrigerant back into the machine opposite of the way you took it out. You will take the discharge of your recovery machine and connect it to the vapor port on your tank. Next, you will take the inlet of your recovery machine from the top of the evaporator and the liquid outlet of your tank to the bottom of the condenser. After you have push-pulled all of the refrigerant back into the machine, then pull the rest of the vapor from the tanks and you're all set. It's extremely important to note that if you make a mistake, you could freeze the machine and rupture your tubes. I've worked with many guys who have frozen up tubes on the machine before because they overlooked something or got in a hurry. It happens, we all get in a hurry sometimes and make mistakes. That's why it's so important to make sure you're trained when doing this, to minimize the possibility of damage or injury. Most manufacturers' training will talk about this but won't actually do it with the guys due to lack of time or resources. If you need to do this on a machine and this is your first time ever, it is not advised to do it by yourself. I recommend you call a senior technician who knows exactly what to do with that specific machine in that specific application. It's better than freezing a machine and causing over $100,000 in repairs or getting injured. So it's extremely important that you pay attention the entire time and you never leave the equipment unattended. Otherwise, you're going to end up hurting yourself or breaking your machine and creating a bigger headache than when you started. If you guys like this video and would like to support us with making more content like this, please like and subscribe so we can continue building a place for us all to share information about chillers and learn from each other.